move on to the other section, which will deal with astronomy and mathematics. Now you can see astronomy, solar system. I'm sure all of you have, or at least some of you have Janampatri. If you go to the history of Janampatri, it goes back to thousands of years in time. I have a Bahi in my family here, which is at least 300 years old, which has Janampatri of my grandfather and great-grandfather. So that is the kind of Janampatri we had. Now Janampatri is based on 9 planetary positions. We call them Navagraha. These planets were discovered by our ancestors long time back, when Europeans had no idea about this whole planetary system. They thought that the earth was flat and sun is revolving around the earth. That was their presumption till 17th century. And then, of course, there were some changes in European thinking. And those people who came out with changes, those who displaced earth as the center of the gravity, they were actually imprisoned for life. And they were not even allowed to come because they thought they were telling all the lies. But finally the truth came out, and it was discovered that the sun is the center of the planet, the solar system in our case. And there are 9 planets. Those 9 includes 2 which are called Rahu and Ketu. And therefore there are 7 which are considered important. Rahu and Ketu are also considered planet, but not so important. Even today, we have the same counting in the modern science of the planets. Our Panchang, if you look at the traditional Panchang in India, you will find it so detailed, because we have the day calculation based on Gadij. So each moment is counted there for the day. Then there is a month which is based on lunar movement, that is waxing and waning of the moon. And then it is converted into solar year. So every 3 years you have an extra month, and all the adjustments are done. So this is a very sophisticated system which was evolved by our ancestors based on the knowledge of astronomy, based on the movement of different planets and different other objects in the solar system. So that is how this whole planetary system was known to our ancestors. You can go back thousands of years in time. Now, we have 7 days in a week, and they are named after 7 planets, excepting Rahu and Ketu. The first day, Sunday is named after Sun, that is the principal planet, and Monday is named after Moon, which is the second most important planet. Now they call it satellite in the modern sense, but this is another planet which shines in the sky and shines with the light from the sun, which is also, you will see, mentioned in some of our ancient great literature. So all these 7 days have been named after 7 planets. If you go around the world, you will find 7 days in a week. There's no place on the earth where you find 8 days in a week, no. And all the 7 days have been named after the same 7 planets. You can see any language in the world, you will find the same configuration of the planets assigned to each day of the week. So this is based on the knowledge, discovered by our ancestors of astronomy long back in time. Now, you see some of the most ancient astronomical writings. There are two of them which are very well known, and the text is still available. There could be little dispute about their antiquity, but the text is available. Like I have the text of Surah Siddhanta on my laptop. I don't have the text of Vedanga Jyotisa, but this is available as well. And you can find the treatise on these texts based on the commentary of our ancient research. Now, Surya Siddhanta is supposed to be at least 5 centuries before the Christ, before the Christian era. It actually calculates. You will see all the calculations are given here. Calculating the motion, orbits, and distance of various planets. It calculates the Earth's diameter to be 8,000 miles. And the modern science tells it is 7,928 miles. So you see the calculation given in Surya Siddhanta that time. Then diameter of moon, you can see 2,400 miles. And modern calculation shows 2,160 miles. Distance between moon and earth is described at 258,000 miles in Surya Siddhanta. And today's modern science tells it is 238,000 miles. The difference is perhaps because of the calculating methods prevailing in those days and prevailing in our days. Because most of the methods and measurements which were used in the past are completely different than those are used today. And therefore you have to convert them to a common denominator called miles, and that conversion leads to some difference as well. So these are some of the details given in Surya Siddhanta, which is at least 2,700 years old from today. Now, Surya Siddhanta also deals with sine tables, cosine functions, measurement of time, meridians, equinoxes, solstices, eclipses of the moon and the sun, planetary rotations, inclination of the planet to the ecliptic, heliacal rising and setting of stars, relative motion of the moon and the sun, and some astronomical instruments and calendar computations. All these have been explained in great detail in Surya Siddhanta. In fact, the modern science has been wondering how our ancestors were able to reach those calculations in those times. Now, some of the great astronomers which India has produced are, very well known. Yavanjatka, Aryabhatta, Brahmagupta, Varahamireya, Bhaskaracharya. These are some of the greatest astronomers of all time. And we will go into some of the writings of Aryabhatta today, and you will see how great those writings are. Now, you see the numericals. If you look at the Roman numericals, you can write up to 1,000 and then you get totally confused because there are so many, complications that keep arising in Roman numericals. The Indo-Arabic numericals are actually the numericals invented by India. They invented here and then they went to the Arabic world and then they went to Europe. So Europeans easily call them Indo-Arabic numericals because they came to Europe from Arab and they originated from India. So the journey from India to Arab to Europe actually changed their name to Indo-Arabic Numericals. But primarily they were all invented in India. The invention of zero, we will look at it when we go to the Aryabhatta today. Then, we can go into atomic times to trillions of years. I have those calculations. We will go into those calculations one day. The atomic time has been explained in Bhagavad Puran. There are verses which explain calculation of time, how the calculation of time starts, and how it keep increasing from atomic time to bigger time, the days, and then the 15 days, and then the year, and then going back what we call year of Deva, and then finally the year of Brahma, that is 4.32 billion years. One day of Brahma is 4.32 billion years, and the year of Brahma is 311 trillion and 4 billion years. We will go into some of them slowly. Now, Mahasankh, one with 9 zeros, decimal system, all these were invented by our ancestors in India. So now let us go to Aryabhat. This table will explain to you something very amazing. What Aryabhatta did was he used 36 consonants and 16 vowels, which are the alphabets in Sanskrit, to convert numericals into alphabets. He denoted each alphabet compared, like K was equal to 1, K was equal to 2, K was equal to 3. Like that he continues up to M, that is Ma, Pa, Pa, Ba, Ba, Ma. Ma becomes 25. That is the straight calculation, 1 to 25. Then he goes to the the later section of alphabets, Yer, Lavva, and that is, he denoted them 30, 40, 50, and 60. And then the last line, Shah, Se, Se, Hai, that is 70, 80, 90, and 100. This is, he used the consonants. And then he used the vowels. You can see A is 10 to the power 0, E is equal 10 to the power 2, U, Re, Re, A, I, O, O. Now, O becomes 10 to the power 16. So, if you have to write 10 to the power 16, you simply write O. You don't have to go into detailed numericals at all. And his verses are based on this particular, what we call, numericals into alphabets. Numericals converted into alphabets is the foundation of Aryabhatiya. Aryabhatiya is the book written by Aryabhat, and this is available, this text is available online. It has 4 parts, which I'll explain to you what they say. But first let us go into the zero. The zero was actually comes from the second. There's a Ganit Pada. Ganit Pada is one of the sections. There are 4 sections in Aryabhatiya. Ganit Pada is the second section. The second verse of the second section defines the place value system. And this place value system is like this. And that is how zero came into being. How, by adding zero, he converted 1 into 10, and then to 100, and then to 1,000, and then to 10,000, and continues like that. So Koti and Arbuda and Vrunda, that is where he went up to, that is 12 zeros after 1. So this is the foundation of inventing zero by Aryabhatta. But some people believe that the zero was invented much before Aryabhatta, because there are clear references even in Surah Siddhanta. which is almost 1,000 years before Aryabhatta. Aryabhatta was born in 400, I think 68 or something, and his Aryabhatiya was written at the end of the 4th century, that is 480, 490 AD, while Surya Siddhanta was written at least 500 years before the Christian era. So even in Surya Siddhanta, there are references to this kind of writing, and therefore many scholars believe that the invention of zero goes back to Surya Siddhanta, not to Aryabhatta, but Aryabhatta very clearly defined the place value system where the zero was placed and the value was enhanced because of placing the zero in a particular way. Then this is the value of pi in Aryabhatta's. He went up to 4 digits. This is the equation which he has used. Add 4 to 100, multiply by 8, and then add 60, 2000. The result is approximately the circumference of a circle whose diameter is 20,000. By this rule, he explained the ratio of circumference to diameter, which is pi. And this is the calculation given here, 3.1416. The value, as you can, of course, can go infinitely further up, but basically he went up to 4 digits. And this, sloka, which is translated into English here, explains the value of pi, which is explained in the verse 10 of Ganit Pada. Ganit Pada is part of Aryabhatiya, and verse number 10 is translated below, which explains the value of pi. Now, I don't have those here, but Aryabhatiya also gave detailed explanation on the planetary position. There is one full section like Ganit Pada. Ganit is basically arithmetic. Similarly, there is an astronomical pada, which gives complete details of the astronomy today. The planetary motions, the planetary systems, how the sun, controlling the solar system, and how various planets in the solar system revolve around the sun. All those precise details have been given in Aryabhatiya. I have not brought them here because it is neither the intention to go into those details, nor it is possible to explain them in precise language, because all those verses are in Sanskrit and they are in the form of verses. They are not numericals. As I explained, Aryabhatta has used the numericals converted into alphabets, and that is the foundation of his Sanskrit verses. But I have those things in one of my articles, which I will send you separately. Now let's go to Hindu calendars. Now Saptarishi calendar is considered to be the most ancient in the world, and this calendar is placed at 3076 BC, that is before the Christian era, 3000 years before Christian era, that is approximately 5200 years from now. So this was the time actually just before the beginning of Mahabharata. So the Saptarishi calendar is the oldest one. And then you have the start of Kali Yuga, which has been very clearly mentioned in Mahabharata. That was, a particular planetary position as also explained in that. And I believe with the computer program of today, you can go back in time to project that particular planetary position. And by reaching that planetary position, you will go back to 3102 BCE. before Christian era. And that position has been explained in Mahabharata, which can be verified on modern computers based on the programs that you go back on the planetary position in time. So this is what the other calendar is, the counting of Kali Yuga. The Yuga started 3102 BCE. Then we have Vikram Samvat, which is very widely used in northern India. We are in now 2080, I think. This is it's approximately 56 or 57 years before the Christian era. So if we add 2020, then we add 57, then that would give the Vikram Samvat. That is the beginning, that is, based on the day on which Vikramaditya was enthroned. He was, given the kingdom on that particular day. So the enthronement of Vikramaditya is the beginning of Vikram Samvat, and that predates the Christian era by 56 to 57 years. And this is actually commonly used in our calendars in northern India today. Now, as we discussed, Jyotish Vedanga is the first Vedic text to mention astronomical data, records events going back as far as 4000 BC. That is the Jyotish Vedanga, which we talked about. That is supposed to be the first ever book on astronomy written anywhere in the world. And this was written in Sanskrit by our ancestors. The Hindu calendars are the oldest in the world. They are also the most scientific. They divide an approximate solar year of 360 days into 12 lunar months of 27. According to the early Vedic text, Tatiriya Samhita, that is what it's mentioned there, 27 to 28 days. And according to Atharva Veda, the fourth of the Veda, that is in this particular verse 19.7.1, and the year was divided into 12 lunar months of 27 to 28 days. The resulting discrepancy is resolved by intercalation of a leap month every 60 months, making 365 days in a year. I explained to that before that we add one extra month every 3 years, and that extra month takes care of these differences in the solar year and the lunar month. Now, I will not go into the time calculation today because this is a very fascinating subject on its own. So we will deal with this particular issue next time. But I want to conclude today the mathematical and astronomical part. So what I would like to say, if you have visited Somnath temple in Gujarat, outside the Somnath temple, there is a Shila lake on which a Sanskrit verse is written. The meaning of that Sanskrit verse is that from that point down right up to the end of the earth, there is no island in that particular straight line. If you take a 90-degree angle from that Shila lake near the Somnath temple, there is absolutely no island right up to the end of the earth, that is up to Antarctica. So you can see the people at that time knew even the islands where they are located on the earth, in the oceans. All those islands were discovered, and that is why they could write that particular verse, which you can find today. And today's measurements have proved that if you draw a straight 90-degree angle from that particular point, you will find no island in the ocean. It is a straight line. So what I wanted to draw your attention is that there's a tremendous amount of knowledge and depth of knowledge in the astronomical and mathematical writings of our ancient sages. Unfortunately, we have ignored that. We have taken to the Western history and culture, in a natural way these days, that all our curriculum is based on that, ignoring these detailed scientific facts which were propounded long time back by our ancestors. So let us make an effort from our side that if we can popularize some of these, knowledge base which was left behind by our ancestors, our children and grandchildren will feel proud of themselves that their ancestors gave such a great knowledge to the people of India and to the people of the world. So I think this is what we should do, and this is what everyone can contribute a little bit in propagating this fact of life and telling our children that we have great heritage, glorious heritage, which has been left behind for us. So thank you very much for joining me today. Now we will have Q&A now, and after that we will have meditation session. If you